Welcome back. In this video, we are going to solve problem 10-85 that is taken from chapter number 10, Strain Transformation, and book name is Mechanics of Material by R.C. Hibbeler, 9th edition. And the topic is related to theory of failure. So statement is the state of stress acting at a critical point on a machine element is shown in figure. Determine the smallest yield stress for a steel that might be selected for the part based on maximum shear stress theory. So you can see this is the state of stress on a machine element, clear, and you have to find the smallest yield stress for the steel using maximum shear stress theory. Now what we will do is that let this is your x-axis and this is your y-axis. So based on this axis and from the given state of stress, we know that sigma x is equal to, in x direction the stress is 8 ksi, while sigma y stress in y direction is 10 ksi, that is compressive. So we will take minus 10 ksi, and the shear stress tau of xy is plus 4 ksi. Why it is 4 plus 4 ksi? So you can see this x represent plane and y the direction, and you can see that this shear stress is acting on the plane, that is x plane, and the shear stress is in positive y direction, that is why this is a positive value. Now we have this state of stress. So what we are going to do is that we will find principal stresses because they are needed. So we will find these principal stresses, and we know that principal stress sigma 1 comma 2 that is equal to sigma x plus sigma y divided by 2 plus minus under the root sigma x minus sigma y divided by 2 whole square plus tau of xy square. Now you have all these values, so just plug it in this formula. Sigma x is 88 minus plus minus 10 divided by 2 plus minus under the root sigma x is 8 minus minus 10 divided by 2 whole square plus tau of xy, which is 4, it will be square. So 8 minus 10 divided by 2 plus minus under the root 8 plus 10 divided by 2 whole square plus 4 square. Okay. So sigma 1 comma 2 will be equal to minus 2 divided by 2 plus minus 18 divided by 2 is 9. So 9 square plus 4 square. Okay. So we can also write sigma 1 comma 2 is minus 1 plus minus. We will calculate this value. So 9 square plus 4 square under the root of this answer will give us, 9 square plus 4 square is this, under the root answer is 9.85. Okay, so we will get sigma 1 will be equal to minus 1 plus 9.85 and sigma 2 will be equal to minus 1 minus 9.85. Okay, so minus 1 plus 9.85 will give you 8.85 ksi. This is the value of one of the principal stress, and sigma 2 is equal to minus 10.85 ksi. Now you have both these stresses. So what we will do is that we are going to find smallest yield stress for this element using maximum shear stress theory. Now you can see that both, I will choose another color, since sigma 1 and sigma 2 have opposite signs, so we will draw them on Mohr circle. Let this is axis on which we can take the shear stress, and this is the y-x axis on which we take normal stress. Clear? So sigma 1 is 8.85. Let's say this is sigma 1, which is 8.85 ksi, and this is sigma 2, which is minus 10.85 ksi. So if I draw a Mohr circle between them, it will be like this. It's a not correct circle, but I'm going to do it for your understanding. And here you can see sigma 3 is equal to 0. And if this Mohr circle between sigma 1 and sigma 3 is like that, and the Mohr circle between sigma 2 and sigma 3 is like that. Clear? It will be like that. Okay. So you can see the maximum shear stress using the maximum shear stress theory. This will be the maximum shear stress, and this maximum shear stress, I will write it over here. This maximum shear stress will be equal to sigma 1 minus sigma 2 divided by 2, which will be the radius. Again, you can see this is the radius here, or this is the radius. So this radius can be obtained if you take this whole distance divide by 2 will give you this radius r, or this will be the maximum shear stress. Okay. Now, according to the maximum shear stress theory, so for failure, your maximum shear stress, which is sigma 1 minus sigma 2 divided by 2, is greater or equal to sigma yield divided by 2. So we are going to find the minimum yield stress. So what we are going to do is that I can write it sigma 1 minus sigma 2 divided by 2 will be equal to sigma yield divided by 2. Or from here, sigma 1 minus sigma 2 will be equal to sigma yield. So sigma 1 is 8.85 minus sigma 2 is minus 10.85. That will give you sigma yield. And at the end, you will get sigma yield will be equal to 8.85 plus 10.85, and that is 19.7 ksi, which is our required answer. This is the smallest value of yield stress that can be used for this problem. So this was all about this problem 10-85. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it, and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.